So now let's take a look at part C. Is a mean stay of 8 days an unusually high value for a random sample of 40 children? Okay, notice again we're still dealing with the average, that X bar value, because we're talking about a mean stay for 40 kids. We're still dealing with that X bar. And so what we'd like to do here is to try to figure out, is this going to be an unusually high amount? Now I'm going to draw a picture here to help try to illustrate the point. Remember that our distribution for X bar, we saw in the last example, had an average of 7.37, and a standard deviation for our X bar was our 0.79 out of our square root 40. So when we talk about the value of 8, we know that 8 exists over here somewhere on the number line. But the question is that we don't know if it's unusually high. We don't know if it falls into the top 5%. So remember that one of our ways to determine if something was unusually high would be to measure the probability over here. That is the area towards the top tail. If, remember, this total area comes out above 5%, then certainly 8 is not in the top 5%. It's not going to be rare. But if it comes out as less than 5%, then we would know that it is rare. So let's go ahead and calculate this probability. We want the probability that we get an X bar that's greater than 8. Since I have a normal distribution, I know I can use a normal CDF starting at 8, going to 1E99, 7.37 is my average, 0.79 out of square root 40. That's what I have here. And you could actually go ahead and try to type this into your calculator to see what you end up with. So I'm going to go ahead and go to my normal CDF. Let's see, this time I'm going to go from 8 to 1E99. And I actually already have all my other values typed in here. So notice that when I go ahead and I hit paste, ooh, wait, what is this? Now some of you already know what this weird sort of value is because you've seen it before as you've been practicing with worksheets and other sorts of topics in this class. But what we see here is that at the very end of this number we have an E-7. Remember, that means that we are going to have scientific notation in use here. This is really this number times 10 to the negative 7th power. Now scientific notation can be overcomplicated to the nth degree, but I think it's really simple to know how to interpret this. Really all this number is telling me is how many zeros there are that occur before this number actually starts. That counts the 0 in front of the decimal place. So here this says that there is going to be 7 zeros before this number starts. That's indicated by the negative. The negative is telling me that it's before. And that counts the one before the decimal place. So if I was to go ahead and actually write this out here, I would have 1, 0, 2, 3, 4, 5, 6, 7. 7 total zeros. And then my number, 2288, I guess if I rounded. 2288. Notice if I rounded this to just like 4 places total, that would be roughly 0, right? Because the first 4 places here is just going to be like up through here. So this is really just 0. It's not exactly 0. There's some chance of this happening, but it's so unbelievably rare, it might as well be 0. It's so close to 0 here. So what we could see is that definitely, is this unusually high? Yes. So I'll say yes. This is very unusual. Okay, well this is the first half of the question, and the first half really isn't the hard part. It's not too bad to measure that probability and to see, yeah, that's really rare. This value of 8 definitely falls into the top 5% because it hardly has any chance of occurring. So what do we do with things like this? Now here's the weird thing. We are going to go ahead and use this probability to try to go ahead and reach a conclusion that's based off this statement down here. Let's read what it says. If you actually went out to the hospital, all right, I need you to imagine this right now. Imagine you actually went out to the hospital and you obtained this exact sample. That is, you got 40 kids, you calculated out all their lengths of stays, you averaged them all together, and you got back the value of 8. Okay, first off, we should be able to say that that's definitely something that could happen to you, right? It could happen. You could go out, you could get a sample, and you could come out with an average of 40. Could happen. Sorry, I mean an average of 8. It could happen. But notice that something weird begins to happen here. Something weird just took place. If a weird event happens to you, just think in real life, if a weird event was to happen to you, you start to kind of ask questions, right? Like, just imagine maybe you like went on YouTube this afternoon and you just started like watching, I don't know, some random videos. And you saw a video where someone, I don't know, say walking down their driveway just threw a basketball over their, just from like over their shoulder, behind their back and, from like 45 feet away, and it just perfect swished into the basketball hoop. That's pretty weird, right? That's like not something you see every day. And so you should have one of two responses. And they're probably the same responses you always have, where you start to go, either, that was awesome and I can't believe that, I'm going to show that video to people. Or two, you might start to say, I don't know, I think it was faked. Right? Like they set things up, they spliced together some video. That wasn't the ball that went through the net, wasn't actually the ball that they shot. Right? I mean, you see this all the time with, say, like if you've ever watched someone do a magic trick. You either believe, wow, they did something that's like totally impossible, or you think, no, there's something more going on here. And so I would say that the same sort of thought process can be brought up in this scenario. Because if you went out to the hospital and actually got an average stay of 8, shouldn't that be, based on the probability, unbelievably surprising that you were able to do that? Isn't that like, whoa, holy crap, I can't believe I was able to get that. So you could think, I'm pretty lucky. Or you could start to think, wait a minute, was this rigged? Did I just like witness, like some sort of like rigged scenario where I just, there were a bunch of planted kids in there and someone wants me to believe that the average stay is 8. You could start to ask questions about, hey, maybe these numbers that the hospital's reporting, 7.37, maybe the standard deviation, maybe those numbers are wrong. Maybe someone isn't telling the truth, right? Maybe there's something more going on here. And so here's the general idea. When we experience something rare, we look for other explanations. So in this case, I ask, if you just experienced this unbelievably weird thing, would you have reason to doubt the hospital's claimed value for the average length of stay? And I would say, yes, we do have reason to doubt the hospital's reported average length of stay. We have some reason to doubt it. We don't know if it's wrong, but we could think, well, 8 right now seems like it should hardly ever happen, so why did it happen to me? I could be super lucky, or maybe it's rigged. Maybe something's off here. And so what we could even maybe start to suspect is, what if this average is wrong, we might start to suspect that actually the right average, maybe if the average does need to be adjusted, maybe it should be a bit higher. Because if the average was a bit higher, that would make 8 closer to being average. It would make it less rare. So this is how we can start to use our probabilities to help reach some conclusions. If something like this happened to me, I would start to wonder if the hospital gave me correct numbers. Notice though, if I calculated this average and I got a probability that was, say, like 80%, then nothing unusual happened to me. So notice, it's only in the instance when we experience something rare that we look for other explanations. If I experience something common, I don't really have any need to look for alternative explanations. Another example of something like this is like, imagine that, you call, say your best friend, you want to catch up for a little bit, right? So maybe you call him up, you shoot him a message, whatever it is, and you say, hey, how are things going? Well, if your friend all of a sudden comes back and just starts like cussing you out like crazy, just out of nowhere, you're experiencing something very unusual. I mean, you're like best friends. Why would this happen? And so you might start to search immediately in your mind for alternative explanations. Maybe they have a bad day. Maybe they have me confused with somebody else. Maybe, I don't know, something's going on with their life. Maybe this isn't them. Maybe someone else has their phone. I have no idea, right? But I start to look for other explanations. But if you call your friend, shoot your friend a message, and they just go, hey, what's going on? You don't start going, oh my gosh, maybe someone else has their phone. This is so crazy. They would say that every single time I asked them a question or started to talk to them, but this time, for some reason, it strikes me differently. No, you wouldn't do that, right? If they're common, if they're doing what they typically do, there's no reason for alarm. But if you've witnessed something strange, you look for alternative explanations. This is kind of where the rest of our semester is going to be headed, and you can practice this idea in this section and in the associated worksheet. In fact, example number 3 is going to be an example that I'm not going to cover here in these videos, but I'm going to ask you to go ahead and try to work through so you can see if you can answer these questions here. And they'll kind of follow the same rhythm and cadence as what we saw in these examples, where I ask a question about a single item, an average of items, and then what can I deduce, or what should I be able to conclude or suspect based on a calculation of a probability? Give those a try, and of course, if you have any questions, please feel free to ask me during office hours.